This is just going to be a brief introduction to some basic electrical terms. Okay, so we're going to look at voltage and current here. The 2 meters you see are both connected to the lamp, which you can see here. Alright, this meter here is the voltmeter. It's going to measure the voltage across the lamp, and perhaps not surprisingly then, this one here is the ammeter that's going to measure the current through the lamp. Now if I alter the power pack, you can actually see the values start to change. So as the voltage increases, you can see the brightness of the lamp increases and the current also increases. So you could look at identifying the brightness in terms of either the voltage or the current. As the voltage increases across the lamp or the current increases in the lamp, then the lamp would actually appear to get brighter. So what is voltage? Well, voltage is actually the energy supplied to each coulomb of charge. So a 6-volt battery would actually supply 6 joules of energy to every coulomb of charge that's actually flowing in the circuit. Right? You cannot get a current without a voltage. Right? Voltage is the push. It's what actually gets the charges in the circuit moving in the first place. If you've got a bigger voltage, that tends to imply that you can have a bigger current. And as you can see there, the current value did actually increase as I increased the voltage across the lamp. You can see the current increasing on the right hand side there as well. Alright, so voltage is the energy being supplied to the charges. The current is basically the number of charges that are actually passing a given point in 1 second. Current is measured in amperes. Voltage is measured in volts. So now you can see the circuit diagram for the very quick experiment I did previously. I've left the symbols for the 2 meters blank at the moment. Okay, and I'm going to fill these in as we go. We've got a variable power supply at the top here. Remember, arrow generally shows something's variable. Right, variable resistor would have the symbol for resistor with the arrow going across it. Symbol for a lamp, right, and the 2 open circles are the 2 meters. Now, the ammeter actually goes in the circuit. It's a circle with a capital A. It should have a very, very low resistance because it should have absolutely no effect on the current that's flowing at all. We measure the currents through a component. This meter is the voltmeter, and we always talk about measuring the voltages across a component. So you're actually connected to either side of the lamp here. The voltmeter should have a very, very high resistance because you don't want any current to actually flow down and through the voltmeter. If you were to put the voltmeter where the ammeter is, right, the lamp won't come on. The resistance will be so great there won't be enough current to actually get the lamp to light. Okay, so these are where we should position an ammeter in the circuit in series with the component and a voltmeter across the component in parallel.